All right, so we are going to just introduce what a function is. So if you look at even the course title, Intro to Functions, it would make sense for you to understand new terminology and some new definitions as we move forward. So the first lesson is going to be looking at functions and relations. So we're going to look at each of those two things, kind of define them, and then hopefully it'll all make sense. So first, what we'll do is we're going to look at what a relation is. So I have it written here. A relation is just a set of ordered pairs. So an ordered pair is just a fancy way of saying a coordinate. In a relation, all the x coordinates are called the domain, right here. So again, notice the terminology. We're just kind of up in our game here, right? I have the domain. That's all the x coordinates in a relation. And all the y coordinates are called the range, all right? So if you look at an example here, name the domain and range for the relation. So again, when you look at these, what do you see? Well, these are just coordinates. How many coordinates do you see? I see 1, 2, 3, 4, 5. All right. So there are 5 coordinates, which means that I have at most 5 x values and 5 y values. All right. So now, how do we write the domain? Well, I kind of said that, well, we know what the domain is, right? All the x values. So the way we kind of write it is we use this squiggly bracket, and then we look at all the x's. So I'm just going to highlight them because I can, and it makes my life a little bit better. So these are all the x values. And if I look, I go from -5, -2, 1, 4, and 7. So they're in ascending order. So that's how we're going to write them. Are there any x values that are repeating? No. So that means that if there are 5 coordinates, I'm going to have 5 values for my domain. So the way we write it, we just write -5, comma, -2, comma, 1, comma, 4, comma, 7, and that is it. Okay, super easy. Now, let's look at our range. So again, I'm just going to highlight all the y coordinates. And then when we check it out, we say, okay, what's the range? So again, squiggly bracket. And it looks like my range is also ascending, -3, 0, 3, 6, 9. Okay, cool. -3, 0, 3, 6, and 9. All right? And that is it. All right? The domain is all the x values. The range is all the y values. And again, we were given this relation that only had 5 points. That's it. All right, so hopefully that makes sense. Okay, so sometimes when we are given a bunch of ordered pairs or coordinates, right, we can connect them or we can draw them on a grid. All right. So again, there's just, I think you've realized this in most of your math classes, that we can represent things mathematically in different kind of ways, right? I can have ordered pairs like up here, or we can graph them like I just did here. So these points correspond to the points that are up here: -5, 3, -3, -2, 0, and so on. And then when I look at it, then you say, well, hey, check it out. Like this is actually just a line, okay? If I were to connect them. But when I'm given the relation up here, I'm only given 5 points. So I'm not going to connect them because these are the only 5 points that are in the relation. Because if I connected them, then what does that mean? That means that it would include every single point on a line, which is like infinite number of points. All right. That's kind of where we're going, right? We can look at coordinates, which is kind of a very basic idea. Then when I put those coordinates on a graph, then I kind of see the picture. And then from the picture, we can establish more patterns. All right. So again, just to recap, a relation is just, can be represented using ordered pairs. or a graph. One new thing is like a mapping diagram. And this is one I have here. So again, x's, now again, when we talk about x, what do we talk about, right? We talk about the domain, right? And then the y's, we talk about the range, all right? So all we're showing here is that if I highlight, so like, check it out, right? This x value of -5 gets mapped to a y value of -3. And then this x value of -2 gets mapped to a y value of 0. So if you've noticed, this mapping diagram is the same representation of these sets of ordered pairs and this graph. All right. So this little island here is the x's. This little island is the y's. This is the domain. This is the range. I also put here independent and dependent. That's probably language that you remember from grade 9. Okay, the x values are what we call the independent variable, and the y values are the dependent. All right. So if you look here, I have an example where I have a mapping diagram. So here I try to find, the top, top 10. Well, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The top 11 goal scorers in European soccer. All right. So here, again, this is a mapping diagram. Now, again, we talked about like how can I represent this mapping diagram in other ways. What we can do is we can, like before, what would you do? You'd have, oops, sorry, let me undo that. Let me get a pen. Right? Like you'd have a table of values, x's and y's, right? And you'd have like, -2, -1, 0, 1, 2, and you put whatever values there. But I can literally do the same thing for this situation here. All right. So now, instead of my x values being like just, x, just what do we put? Well, we have a player, right? And then we have the y value or the range is the goals. And then you can just go like, so here I have Benzema. And then I say, well, what's his, so he scored 21 goals. Pretty good season. And then who's next? We have Haaland. And he scored 25 goals. Right, we have Lewandowski. I'm just going to write Leva because his name is long. He had 36 goals. Silva, 25. Messi, I think 25. Yeah, 25. Ronaldo, 25. Kane, 21. Mbappe, 25. And we can keep going, right? Might as well finish this off. Lukaku, he had 21. And then we had Onuachu, who had 29. And Mo Salah, who had 20. All right. So again, like we have here, like I said, this is what we call a mapping diagram. But then I can represent this mapping diagram using this, like a table of values, which is stuff that you've seen before, right? Table of values. All right. And again, what else I can do? Well, I can write these as coordinates, right? So for example, right, I can have, like, I know Benzema, right, is the input, is the player, and Benzema had 21 goals. So you could write each of these as its own coordinate. Okay, this stuff ignore because we'll get back to this in a second. But again, just getting used to the different ways that we can represent a relation. All right, so hopefully that's not too confusing. Another way that we can represent a relation, or kind of how we're going to get from a relation to a function, is an idea of like a machine. So say, for example, okay, so I have like my x values. Okay, let me delete this. This is right. My x values are things in my domain, and they're going to be put into some machine, right? And the machine is going to give me y values, which are going to be called the range. And if you remember, the y values also we call the dependent variable. Now, what does the machine do? Well, that there is kind of the concept or the idea we want to look at. Like, say the machine does this, is x squared. So what does that mean? It means every input, when it's put into the machine is going to square it and get an output. All right. So that means I'm going to get, right, when x is 1, what's 1 squared? Well, 1. And then x is 2, what's 2 squared? 4. And then x is 3. 3 squared is 9. And it's 4, it's 16. So you get the idea, right? 25, and then 36. All right. So now what is the machine? Well, the machine, like, what can it do? Well, it can do lots of stuff. Okay. I mean, say if I took this away and I inputted, I changed the rule in the machine, right? If I did like x plus 1, then my outputs would change. Okay. So really, this is kind of how we're going to get into this new thing called a function. Okay. And when we use this idea of a machine, what I kind of want us to talk about or think about is I have my x values, or my domain values, which we call inputs. Okay. So they're input values that go into the machine. Here, right, this is my rule. And then I get the y values, or what we call the outputs. All right. So like this thing here, right, the rule that I was talking about, that happens to be x squared, that is how we're going to move to the next phase of our discussion, which is what is the idea of a function. Okay. So again, I have inputs, I have outputs. Inputs are just domain values, or x values. Outputs are range values, or y values. All right. And then the rule is going to determine whether it's a function or not. So hopefully that makes sense. All right. So this is kind of what we're talking about here, right? We're also talking about like the machine, right? This is the machine. Now I'm calling the machine a function. That's the function. That's the rule that's going to be applied to whatever inputs we have to give us the desired output. And the rule is always going to be the same. Okay. We're not going to change it midway through, at least not in this course. All right. So here's one of our first kind of formal definitions here, or where we're starting to shift from a relation to a new term of function. So a relation can be any kind of relationship between sets of numbers. Okay. But functions are a kind of relationship where there's only one y value for every x value. Okay. So what that means is that for every output, right here, for every output, for every input, there's only one output. So for example, if we look at the one we just did, right? Oops, I don't want a crayon. right? If these are all my inputs, the function is x squared. So what are my outputs? Well, what's 1 squared? It's 1 squared, which is just 1. 2 squared, which is 4. 3 squared, which is 9. 4 squared, which is 16. 5 squared, which is 25. And 6 squared, which is 36. All right? Now, oops, sorry, I kind of spoiled the next question, right? So we say here, well, okay, for every input, there's only exactly one output. So if I look, well, okay, if x is 1, right, so look here, x is 1, there's only like one output, which is 1. X is 2, there's only one output. When x is 3, there's only one output. When x is 4, there's only one output. When x is 5, there's only one output. When x is 6, there's only one output. So this, yes, right? So the example like this that we look at is a function, right? These inputs here, 1, 2, 3, 4, 5, 6, when they're squared, that is a function. Okay. If I look here, so here's a little picture of like an ellipse. Okay. Now, if I look at this, if you check it out, so let's just look at here. Okay. This point here. Here, x equals 1. Okay. Now, if you look at x equals 1, if I look, I have an output here, but I also have an output here. Now, this, right, is a problem. All right. Right, because x equals 1 has 2 outputs, right? Because when x equals 1, we get y equals, I don't know what this is. This looks like, I don't know, we can say 2.5. But then when x equals 1, I also get a value of, around the same thing, negative 2.5. So this example here, or this type of shape, this ellipse, right, is not a function. All right? So hopefully that makes sense. Now, one trick that you may have realized, or some of you who have seen this before, if you look at this, for example, here I have a circle. If you can draw a vertical line through the relation that you have graphed, and if it crosses the function in 2 points, or sorry, I'm using the wrong terminology. If it crosses the relation in 2 points, then it's not a function. So if you look here, right, like I just drew a line, like, so here's right, I have this is x equals negative 3. I got 2 outputs, right? So not a function. Okay. And you can keep drawing, like I could draw not an infinite. Well, I mean, technically you can, but okay. But like, look how many vertical lines I could draw. And these cross the relation in 2 points. So we call this the vertical line test. So if the function fails the vertical line test, then it's not a function. And it only has to fail it once. All right? Because someone could be like, hey, well, if I put a dot there and put a line, it only hits it once. If you kind of skim the side of the circle. That's true, but everywhere else it fails the vertical line test. So that's usually pretty easy for graphing. You look at a graph, if you look at it thinking with the vertical line test, it's generally not going to be a function if it fails it. Here is, I just drew a little parabola. If you look, right? Now we already talked about it with the points, right? If I just go back here for a second, or sorry, here, not here, down here, right? We kind of talked about this with the inputs and outputs. But here you can look, if I have the graph, well, does it fail the vertical line test? Well, look, anywhere, like here, it just crosses once. Here, it just crosses once. Here, it just crosses once. Here, crosses once. So there's no spot on the parabola where it will fail the vertical line test. So it passes it, so that means it's a function. Okay? So now all we're going to do is just introduce the idea of function notation. All right? So, and this is kind of the next new idea, right? We talked about relations, how we can represent things mathematically. We introduced the definition of a function, and now we're just introducing a new notation. So here, when you look at these equations, right, generally we write it as y equals x plus 1, y equals x squared. The only thing that's going to change is we're going to replace y with this notation. Okay. So if you look, this is like f, so nice curved kind of f, bracket x, close bracket. So you may be thinking, like, how do I say that? Or like what, when we refer to a function, what does this represent? Okay, and really all it does is represent a notation. So like this is how this is kind of like, this is also like new grade 11 stuff, okay? This new notation, which you have to get used to. Okay, so here the f and x, the way we kind of talk about it is this way, right? So it is the value of the function when x is whatever. Okay, so whatever the input is. Okay, so if you look down here where I have like, this f bracket 2, what does it mean? Well, it says when x equals 2, what is the y value? Okay. Now remember, when I say the y value, what does that mean? That's the same thing as like, what is the output? Okay. Now, how do I say it? Like when you listen to the notes, when you listen to the lessons in class, you'll probably hear me say f of x or f at x. So that's how we say this, like this notation. Okay, f of x or f at x. All right. And just down here, one disclaimer, f of x does not mean f times x. Because some students, like, you know how it is, right? Like when you see something like this. Okay, oops, sorry, I kind of screwed up that, right? X plus 1. Right, what do we do? This bracket just means multiplication, right? Like in between the 2 and the bracket, I multiply. Right? This, though, this is a notation, which means that this isn't like an algebraic expression. This isn't saying f times x, because what the heck is f? Right? F would have to be like a variable. Okay? So just remember, this is a notation. It doesn't mean f times x. So hopefully that makes sense. So now we'll just do some pretty simple algebra questions with this new notation. So we want to determine f. So just remember here, I'll write this down, right? When I have, what does this mean? This means f at 4, okay? So I'm given this function here, and all I'm going to do is evaluate it or determine the value of the output when the input is 4, okay? So let's write that out. So f of x equals 2 over 5, x plus 11, okay? And then, well, what's the input? Well, the input here is 4. So I'm going to plug in 4 wherever I see an x. Okay? So now that's a 4 in there. And then now all I do is I just perform the operations that are in this function. So this is going to be 8 over 5 plus 11. And then now, if you remember, I need common denominator, right? So this is going to be 55 over 5. So I believe my answer will be 63 over 5. So f for equals 63 over 5. So this is my answer. So again, what does this mean? And this kind of, I'll be repeating this often, but like once you get the hang of it, you can kind of, you don't have to be thinking about this all the time, right? This means when the input, remember, what does the input mean, right? When the x value is 4, the output, okay, or the y value, is 63/5.
Anyone around to help with groceries?